Example 1. Consider this picture. For example 1. Chapter 4. Heat and bulk. Consider as a system the gas in the cylinder shown in this picture. The cylinder is fitted with a piston on which a number of small weights are placed. The initial pressure is 200 kilopascal and the initial volume of the gas is meter cube. So with heat addition to the system, let the volume of the gas A, heat addition, and let volume of the gas increase to stage 2. While the pressure remains constant, calculate the work done by the system during this process. The work is a path function and we have inexact differential, so we write the work from point 1 to point 2 PdV for the constant pressure dV dV second minus V1. The work is kilopascal multiplied to 1/10 minus 400 equals to 12 kilojoule. And part B, we have considered the same system and initial condition, and B but at the same time the heat burner is under the cylinder and the piston is rising. Remove weight from the piston at such a rate that during the process the temperature of the gas constant. So with heat addition and weight and remove weight, T is constant. Calculate the work for this process. What is work? It is also a quasi-equilibrium process with the relation from the ideal gas. We have this relation. In the case of temperature constant, we can calculate that PV is constant. So we have the relation for the PV constant. And second volume are also 1/10. Pressure at point 1 can be is now and is 200 multiply V at point 1 multiply the ln equals to kilojoule. Part C, consider the same system and state m cube, but during heat transfer remove weight at such a rate that the expression we have a polytropic PV constant. Calculate the work. In this case n equals to, and W is P second V second P1 V1 from the one minus n, or equals to constant on 1 V second minus V1. The constant is, in this case, is P1 V1. So P1 V1 n V second V1. In this case, W can be calculated. P1 is now, V1 is now 1 minus multiply to V second now multiply V1 also now. So W can be calculated and is, or we can first calculate P second at this relation P1 multiply to V1 on V2. In this case P second is and calculate from this relation 1 minus n. And the part T, consider the same system. In the first example, but let the piston be held by a pin so that the volume remains constant. In addition, let heat be transferred from the system until the pressure drops to 100 kilopascal at the same volume. In this case, because of the work is 0, because no displacement is acquired and the work did not cross the boundary of the system, but we have heat transfer instead in this system because of the pressure change. This is the end of the example 1.